Alright guys, so today we're going to do the notes, okay, air pressure notes, and we're going to quickly, we're going to start right there, and I'm going to get my pen ready, okay, so I'll write all over this thing, okay, so we have air pressure, alright, and it's because of air, and what's the layer of air around the earth? Because of the atmosphere. Okay, you need to make sure, because I know your diagram is kind of small and dark, and some of the arrows are kind of disappearing, so make sure you add arrows, okay? That air pressure is all around us, and it's also in us as well. So air pressure is inside us too, okay? Because if we had air pressure just on the outside, we'd be like imploded and squished. So we have air pushing out and in, okay, in. And so that equilibrium makes sure that we're not exploding or imploding. So yay, equilibrium. You should know that word because I think it was on your article of the week. Okay, so next thing, air pressure. So again, it's pretty heavy at sea level, right? Why is it pretty heavy at sea level? This is because, right, gravity pulls air down to sea level, and so we feel the air. That's why when you're underwater, you feel all that water under you. Well, we're used to the air being on top of us, so it's not that big of a deal. But it is pretty much equivalent like an elephant balancing on a desk. So it's like a ton of air just pushing down on us. All right. So the next slide, what you need to do quickly is write down what we just learned, the vocabulary word. So what is it? Yeah, air pressure. Okay. And then you need to come up with your own definition. Okay. And so what we came up with the other classes is the, oh, well, I can't write it. Okay, thanks. Okay, so it's the force of the atmosphere pushing on objects. Okay, and so hopefully you have some kind of definition. You can pause this real quick, write it down, or write your own definition. Okay, and so air pressure, okay, if there's more air pressure near Earth's surface, right, there's more just air. So there's more air, so more air pressure at sea level. So this is the sea level right here. And then it's less when you go up, right? Because this starts to, right, these are falling. And why are they falling? Why are they air molecules? So these are air molecules, okay? Why are they falling? Because of gravity. And so as density, so the density, where's the density the most? Up here or down here? So you should say it's, right, there's more dense here, and it's also higher pressure on the bottom, right? There's less pressure at the top. There's less density. Sorry, my drawing is, I'm trying to use this thing, so I'm trying to be fancy. But again, there's less pressure up here, and there's less density of air up here. So they both are linked. And then if there's, right, it's more dense at sea level, there's more pressure at sea level. So let's go to the next thing. Okay, so quick, what is atmosphere? Can't really turn and talk. So quickly, you're going to write down what is atmosphere. So atmosphere is layer of air. So it's just a layer of air. So there are atmospheres on like Venus and Mars, but they're not like ours, but still they have a layer of air. So I'm not going to say layer of air of Earth because we still use the word atmosphere. Okay, so air pressure. So we're talking like layers of air, okay? So air pressure is like blankets. So the more air you stack on top of each other, the more pressure you're going to feel. So when you're at sea level, it's like you're under a ton of blankets. So this cat right here has a ton of blankets. And this is supposed to be at sea level. So if you can't read that on your sheet, that's what it's supposed to say, sea level, okay? And then when you're on a tall mountain, like right here, okay, it's like you're under a few blankets or even just one, like in this picture. Okay, so the higher you go, the more blankets you're going through and the less that's still on top of you. Okay, so you're going to quickly write where's their air pressure, where is it higher, on a mountain or a beach. So 5, 4, 3, 2, 1. What? The beach, right? Because at sea level, right, equals sea level. Okay, sea level is, let's see, this is the beach. Here's the sand. Okay, if you see the sea, that's that nice that beach body with that. I think maybe that's a swimsuit. Okay, if you're standing right where the ocean is, okay, that's sea level. And there's my shark. And there's I don't know. I don't think I can draw with this stuff. That's teeth. I tried. So why? Because there's more air at sea level. So if there's more air, there's more pressure, which means that there is more density, right? Okay, so you're going to quickly, what do you remember from hot and cold air? Okay, and then I'm going to... All right, so you should have something sort of like this, where you have hot air rises, okay? Oh, am I just... Okay, there we go, okay, so I'm going to highlight. Okay, so hot air rises, okay, spreads out, because so we have these air molecules, okay, that are rising and spreading out. So it's, so what is it? Is it less or more dense? So it should be less dense, and I'm writing with highlighter now, it's kind of weird. So it's less dense, okay, so it's spread out. And then you should have said something like cold air sinks and condenses. So right, squeezing, and it's in one little area. So if you have more on top of each other, there should be more pressure. So more dense, more pressure. Okay, and then if you said something like convection currents, okay, you do have this cycle. So warmer rises, cools, sinks, and condenses. And so you have this current of air, and that is actually how you get wind. Just so if you want to know, we're going to talk about it later. Okay, so, oh, draw a picture here. Okay, thanks, we already did that. Okay, so cold air, okay, it creates high pressure. So this is the next slide. And high pressure looks like this weather. So it's like a nice day. And then I want you to make sure you write it down. Okay, so the weather, it's nice weather, it's sunny. Okay, so the way that I remember with the H is that, right, we're happy. Okay, so high pressure, happy. And also, how are the air molecules? So for the air molecules, they're mostly at the surface. So I'm going to draw molecules on top. I want you to do the same. So that means it's a cooler day. It doesn't mean it's cold. It just means it's colder. So there's cool air. Okay, and so all of those clouds, there's not that many clouds out there. It's all that's staying at the surface. Okay. And so the next thing we have hot air. So hot air rises, okay, and creates a low pressure. And so the air molecules have risen, okay, right, because warm air rises, and it's risen all the way up in the atmosphere to a point where it condenses and becomes a cloud. Okay, so that weather is, it's stormy weather. You make sure you write that down. Stormy, and then cloudy. Okay, so it is not very happy. So kind of lazy, a lazy day. You don't feel like doing much when it's raining. Okay, and so the next thing, turn and talk. So you can do that if somebody's next to you and they're on your thing on that slide. But what you need to do is figure out what the causes, high pressure are, and the effects. Causes and effects. Okay, so so here's high pressure and low pressure. Okay, so what causes high pressure? Okay, the temperature. Okay, so what type of temperature? So it is cold